Hello everyone, welcome to week 5. We're getting into the middle of the semester, so I hope everyone's doing well. Today is going to be, the next 2 weeks are going to be a little bit easier on you. So today's exercise for week 5 and lab is some more boss milling, which is something we've already done in the past. So hopefully you'll be familiar with it and you'll be able to go through it pretty quick. This is the part that you're working with. This is the tutorial as I opened it from Blackboard. You'll see that the facing on the backside is already complete. So on the top faces we're going to be facing and then milling the boss. And then we also have some levels pre-made. So we have a wireframe stock geometry and we also have a solid stock geometry. WCS is the same as the stock geometry, but it's just there. So that's showing you where the corner is. And if you just want to preview that, you can go to planes and look at the Op10 G54, and you see that it's on the bottom left-hand corner on the top of the stock, I believe. So if we highlight this, oh, it's on the top of the part too. So it's Z0 is the very top of the part. And then just for reference, the PDF that you should be looking at is this guy right here. It is the 3-1 MT square boss tutorial. And then we also have a blueprint that is just, you probably recognize it. It's the same one we used for reaming the last time. However, you'll notice there's no holes in it this time, right? We're just doing the outside square boss. So you don't need to do anything with the holes. You're just going to be milling the square here. All right, so let me keep this tutorial open. Again, we'll probably be able to walk through this pretty quick, I would imagine. The tutorial itself is long, the PDF is long, but we don't need to follow it word for word. We're going to be able to rip through this pretty quick. Let me turn all this level off. Here we go. So if you're following along, we're going to create edge curves first. You'll notice that we don't have any edge curves right now. Level 400 is the one we're going to use. In order to use it, we have to make it visible and active. So I'm going to make it visible first. And then I'm going to click the number 400 right next to that and make the blue check mark move down. So that means everything that we create is going to end up on that level. We are going to go up to wireframe. We're going to use curve on all edges. I'm going to zoom out so I can get the entire box or the entire part in a pick box. And selection. And there we go. One thing that we should do is actually make this a 3D wireframe. So let's go back for a second. I'm going to hit X on this and hit cancel and undo. Now we haven't talked about this yet. So in the bottom, like the middle of the screen here, you'll see that the C plane is a 2D or a 3D toggle. And again, the C plane is the construction plane or your drawing plane. If we do a wireframe with only 2D active, I'll try it again just to show you. If we do that with 2D selected, you'll see that we only get lines on Z0. Okay, it's only a 2D representation. If we want it to wrap lines all the way around the part, we need to change that to 3D C plane. So I'm going to do that now just by left clicking on it and changing that to 3D. Hopefully everybody can see that. Now when we go to wireframe, curve all edges, and we select the part and selection, you see the difference here. Now we have lines on all of the parts, not just on the wireframe. Now sometimes this may not be a good thing, and one of the things we may want to look at later is whether or not these are going to mess with our chaining. If they do, we'll delete them, okay? And in that case, it may have been better to leave it a 2D wireframe. But for now, let's do it this way, because this is more like the more likely scenario that you're going to be using later on. So my edge curve level has 52 entities on it. Yours should as well. And now we're going to move on to facing. So there is a write-up on page number 6 as an overview talking about facing. We're on page 7. We're going to face the entirety of the part. And what I would like to do is make sure the stock is turned on. So inside of levels, I'm going to go ahead and turn solid stock on. And let's use the solid surface as a facing point. So we want to make sure that our insertion point is in op 10 and not in op 20, so this is perfect. That's all great. We're now going to go to toolpaths and we're going to go to face. Now for chaining, let's just double check. Yeah, solid stock is turned on. We want to select the solid face, so we're going to use solids. We want to make sure that the 3D button is checked, and we're going to want to make sure that the face selection method is active. You can turn off loop if you want to. You always have to have one of these turned on. In this case, face is perfect. We're going to click on the solid surface here, left click on the top so it highlights. Everything is continuous all the way around, that's good. And we're going to click OK. Now, inside of our toolpaths, 2D toolpaths facing, we see we have one chain geometry, that's great. We have facing selected. We're going to go to Tool, and we should be using our 2.5 inch rougher. Let's just double check. Yep, our 2.5 inch face mill is selected. Let's reinitialize our speeds and feeds just for ha-has. Good stuff. And now for a comment, we're going to say face to clean. And it's going to take 20 thousandths off the top. So that means our stock is currently 20 thousandths bigger than it should be. That's perfect. And again, this will tell the operator what's happening. We'll skip through holder. We don't need to do anything there. Cut parameters is where we do most of our heavy lifting. So zigzag is going to be our style. That's good. We're not going to leave any stock on the floors. This is our finished pass. We're going to leave 15% for our overlaps along and across. Approach and exit stays 100%. And again, this is percentages of the tool width or tool radius. This is all perfect. Max step over 90 is good. We don't want to ensure a number of you. We don't care if the passes are even, so we're having that unchecked. And we want to make sure we do it using high-speed loops. So between cutting, the speed's gonna turn up and rapidly approach the part for the next cut. So it's a time-saving thing. Everything else looks good. Depth cuts, we're not going to do anything with because we're going to do it all in one pass. And in linking parameters, we have our standard values here. So clearance should be 2 inch absolute. Retract should be 0.25 absolute. Feed plane should be 0.25 absolute. Top of stock is 0.02, which again comes from the fact that our stock is currently 20 thousandths bigger than the part. And since our part level is Z0 at the top of the part, that means our top of stock is 20 thousandths in the positive direction. And again, for the same reason, that means our depth is 0. And I have to double check that. So I'm going to click on depth. I'm going to turn the solid stock off. And then I'm just going to click the top of the part anywhere. I'll get this radius and make sure it says 0 when I come back in. Perfect. So that's how I know the WCS is correct and that there isn't any issues with anything else. Let's see. Now I don't believe we have to do anything but backplot. So we can click OK. Oh, yeah, the notes in the PDF through page 21 talk about confirming Z0. So we can go back into the tool notes and just go in here and say Z is going to be 0.0. And we talked about why that is, so we don't need to read through all that and explain it. We're establishing 0 on the part, basically. So in this case, we can click OK. We should be done, and we should have a nice tool path. Looks good. And again, I'm going to use backplot to check most stuff because it just gives you more information. You have a little more control, and it's a little bit less jumpy than the verify. So you want to check top and bottom, so I'm going to check top first, or top and right, I mean. So I want to make sure my tool's actually cut and everything looks correct. And then I want to make sure I look at it from the right-hand side too as well, because I want to make sure that the tool is in the position that I think it should be. So it's touching the top of the part, which is good. I'm going to right click and go to isometric, and now just let that run a little bit faster just so we see. And again, I'll confirm that it's hitting everything. Yep, perfect. Excellent. So that's our facing. And we're going to do that almost on every part we do, so that's a good one to get used to and do a lot of. I'm going to go ahead and save this. I recommend you save it as well, just because you never know when something bad's going to happen. So, and again, I'm just going to put my last name in front of it. There we go. Good. So look at that. We're already on page 23. We're doing great. So again, there's an overview explaining what milling, roughing, and finishing is. We've talked about this. You know, roughing, you're going to leave material to finish, and finish passes are going to take less material, move a little bit faster, and the reason for that is so that the surface finish on the part is better. So let's see. We're going to go and make sure our solid stock is turned on again. We're going to be using that again, looks like. And it's visible. Not worry about making it active because we're not going to be doing anything else. Let's see. Yeah, we can leave the other levels on. It talks about on page 24 how to turn everything else off, but I mean, we can do that if you want. It's not a big deal. Basically what we're going to do is select the solid stock as the outside profile. So if you turn everything else off, there's no way for you to accidentally click on something you shouldn't be. So page 25, we're going to use dynamic milling, okay, which shouldn't be a surprise. We use that for pretty much, well, for a large majority of our milling operations. We're going to start by selecting our machining regions. So what we're going to do is select the cursor in the machining regions box. And what we'd like to do, however you want to do this is fine. I'm going to go ahead and use the face like the tutorial says. So our milling region is basically the entire square block of the stock, which is good. Going to click OK. And then we're going to be actually coming in from the outside in this case, because we don't want to be within these boundaries. We want to be able to actually exit that area. So our tool was going to machine the outside corners of the part versus being stuck inside and then leaving a tool radius in the corner like we've talked about in the past. So that's all good from outside. Now we have not done an avoidance region, which I think is what we should be doing. Let me just skip through the that's good. Yeah, so we're going to do an avoidance region. So on page 30 is where we do the avoidance region. And again, that's the cursor right here, this cursor button. And we can click on the avoidance region and then look at our levels and figure out what we need to do. So we need to highlight the inside structure of the part. So in order to do that, I'm going to turn on the part and turn off solid stock. I got to make the part active before I can turn off solid stock. There we go. So this is the area we don't want to machine in. Okay. So what we're going to do is we are going to highlight the outer area of the chamfer, which we can do a couple different ways. If you look at page 31, this is where we actually use our wireframe geometry. So if we turn on the wireframe or the edge curves, level 400, now this is where we actually probably should have left the 2D wireframe together, because when we go to chain the wireframe here, what's going to happen, I'll show you, we go wireframe, C-plane, and then chain. What's going to happen here is when you try to click this and use loop, it won't actually loop all the way around. Oh, no, in this case it did. How the hell do you like that? Never mind. I thought these lines were going to cause us an issue. Sometimes they do. I don't know why Mastercam was smarter than usual in this case. This is the chain that you want. So you want the entire loop of the outside of that bottom of the chamfer. The reason why we're selecting the bottom is because that's actually the outside profile of that boss. You see that? If you click the inside by accident, what happened is your feature is going to be too small because it's actually going to be machined to this area. So good, that's perfect. If your chain looks like that, you're good to go. I'm just going to click OK here. So we're going to basically machine in this between this rectangle here over to the inside of that chamfer there. So perfect. I'm going to click OK. And now we're in the dynamic mill toolpath box here. So just double checking again. So our machining region has one chain selected from the outside, and then our avoidance region has one chain. So that's perfect. Dynamic mill is selected. We're going to go to Tool, and we're going to be looking at page, looks like number 35 now. We're going to use the 3/4 roughing end mill. And our comment is going to be rough the boss, or rough boss. In this case, we're going to leave 20 thousandths X, Y, on the floor and the wall to finish. And we're going, oh, I'm sorry, no, X and Y is like on the boss itself, so 20 thousandths on the boss, and then we're going to leave 10 thousandths on the floor, which is that ZSFF note. And our final Z depth is going to be Z minus 0.290. And we will confirm that, you know, on the part when we're looking at this stuff. So that all that information is on page 35. And let's go ahead and reinitialize speeds and feeds. And we'll continue on. So there's no holder. We're not looking at stock for anything. And now we're in cut parameters. So we're going to climb mill. Tip comp is tip. We have an approach distance of 1/8 of an inch, which basically means 1/8 of an inch outside the chain, which is fine. That's good. We'll change that. No first pass offset or any of that. Our step over is 50% or 3/8. Our toolpath radius minimum is 10% or 75 thousandths. And our gap size, we're going to say a distance of 3/4 instead of percentage of tool. So I'm not sure what that should do. The number's the same whether you use 100% or 3/4, so not too worried about it. And then our stock to leave on the walls, again per the note, is 20 thousandths, and then on the floor is 10 thousandths, and that's 0.02 and 0.01. Now we do a micro lift distance and a back feed rate. It's mentioned in the PDF. I don't do a lot again with this, and these are the defaults, so we're just going to leave those alone. And it looks like our step over actually, so according to the PDF, the step over is 90%, which is very aggressive, which makes sense actually, but if you look at the picture it says 50. So we'll go with the 90% step over, and again, which is very aggressive. We'll see what that looks like on the screen when we go to backplot it. Depth cuts is going to be turned off. We're doing it all at one pass. Now entry motion, we're going to uncheck because we're coming from the outside of the part, so we're not actually helixing into the material. That's why we're not checking that. There's no breakthrough because we're not breaking through anything. And now in linking parameters, again, we're used to this. Clearance of 2 inches, absolute. Retract, quarter, absolute. Feed plane is a quarter, absolute. Our top of stock is now 0 because we've machined all that material off. And now our depth is going to be an absolute -3, but we'll go ahead and check that. So when I click on depth and I click on the bottom surface of one of these, it should be 0.3. Now you will notice that in our tool note it says our depth is Z minus 290, right? Not 300. And again, that's because of this number here. So this gets subtracted from our depth. So if the depth is supposed to be 300 thousandths, you take 10 from that to get the -290. That's how that works. Arc filter tolerance, I've mentioned this before. This has to do with how it generates radii and circles. So a computer, or computers in general, they generate circles using chords. So the smaller the total tolerance, the smaller the lines that it generates. It's drawing a circle. So it looks like we want our total tolerance to be 5 thou. Our cut tolerance is 0.0025 per the PDF. And then the percentage is cut tolerance is 50%. And then output 3D arcs should be turned on, which is down here in the bottom right hand corner. So this is basically a way to tighten up your tolerancing on your radii. You just got to remember that the more the tighter this is, or the smaller the tolerance, the more lines it generates, so it uses up a lot more code, memory on the computer and memory in the machine. Not to mention it's tough on the motors and things like that in the CNCs. So basically, I don't usually go in here and do much with this. I leave them default. But since the PDF is calling it out, we should just do it the way it's calling it out. So, page 45 kind of explains that again. Again, it mentions a ridiculous amount of code, so we're just filtering some stuff so it's not as obnoxious. And now we're going to go ahead and backplot. So we can click OK on this. We should have a nice toolpath. I'm going to check my top view first. I'm just going to have my 2D high speed selected. I'm going to backplot that and just make sure it looks the way it's supposed to. So a tool again is allowed to go outside, so you see it's clearing all the corners. And that's going to come in here. Looks pretty good. We'll let that run. You'll notice that it's not touching, right? There's our 20 thou on the face. And then I'll also check the floor and make sure it's not touching the floor yet either. And you're going to want to do that by right-clicking and looking at the right-hand side or the front. Actually, the front in this case is probably a little better. And you'll see the tool is actually not touching the bottom either. And that's exactly what we want. So now that we've finished the roughing operations, it's time to do the two finishing operations. So starting from page 49, we're going to look at finishing the floors first. We're going to go ahead and copy the rough boss toolpath because the chain is the same. So my method, again, I highlight number 2, the one we're going to copy. I'm going to right click, hit copy, and then I'm going to right click next to the red insertion flag right below it. I'm going to hit paste. And that's just the way I like to do it. 51, page 51 explains how to do the Control C and the Control V method. Now we're going to go and edit our parameters. So I'm going to open the plus button next to number 3 and hit parameters. We'll go back up to toolpath type and just review the entire thing from top to bottom. So we're going to turn this into an area mill rather than dynamic. We're going to modify the tool. We're going to use a 5/8 finish end mill. We're going to reinitialize the speeds and feeds. And then, let's see, we're going to have to modify the comment here. It may happen later on, but let's go ahead and modify it now. So we're going to say finish boss. And we're going to finish the floor. So our Z minus is going to be 300 because we're taking that 10. And then we're going to be removing the note that mentions the 10 thousandths on the floor because we're going to get rid of that. So we're just going to leave that there. That looks good. We're not going to do anything with the holder. We're not going to do anything with the stock. Inside of cut parameters, we're going to change the step over XY to 75%. And again, that's based on the diameter of the tool. Keep tool down within distance 5, which I believe is the entire width of the block. So I'm not exactly sure what that is doing there. Keep tool down within. We'll have to look at that, and maybe I'll explain it to you guys a little bit later. Now the stock to leave on floors and walls is the important one. So we're going to set floors to 0. And then we're going to leave 10 on the walls. So we're going to cut a little bit. We're going to take half of the amount that's left. And if that's the case, I screwed up on the note. We should go back into the tool note and put that back in. So this is going to be just change this. So we're going to have 0.1 left over in the X and Y SFF note here. So we're going to do that. Depth cuts is disabled still. That's good. No entry motion stuff. We are going to no breakthrough, obviously. And then linking parameters, we should be pretty close to here. So clearance, retract, and feed plane are all the same. Top of stock is still 0. They actually change the top of stock and feed plane to -3 here, which I don't get. I don't like that at all. We're just going to leave those alone. So leave retract and feed plane at 1/4 of an inch. That's fine. This is making it so that it doesn't go, like, it doesn't have to retract or travel as much, so it saves time. But for what we're doing, I want to leave these alone. Top of stock is actually different because we've machined all this stuff away. So a top of stock of -3 isn't going to hurt us at all. That just means that the top of stock is down here. If we do retract, so just if we do retract and feed plane at -3, that means there is no retract or feed plane. It just happens right at that. That's why I don't like it. And then our depth of -3. So good. That's all good. It's on page 63 if you want to review that. Yeah, so number 64 explains that plunge off the part. Yeah, you can read page 64 if you want to read through that. And then HST leads. Again, I don't really do much with this. This looks like it's the vertical pull off the part when it's coming in and out. So if we set this to 0 and 0, that just means it's not going to ramp up in the Z. It's just going to come straight off the part without that little arc on the back, the J arc there. Now that's it for that. Now we can back plot. So I'm going to hit OK. We're going to regenerate that toolpath because we modified some parameters on it. And then we're just going to back plot it again. So I'm going to look in the top view first, make sure that all of my moves make sense. I can speed this up a little bit. Looks pretty good. Again, leaving 10 on the wall still, so that's good. And if I look in the right hand side view, the tool should be touching the bottom of the part, which it is, or the bottom of that surface. Excellent. So we are all done with that. Now we're looking at finishing the walls. So we are going to go to page 73, and this time we're going to use a contour. I'm going to select all of my toolpaths and then hit the toggle display on or off and just hide all the toolpaths so it makes it a little bit easier to see. This next command is going to be a contour. Toolpaths contour. And for our chain, we are going to use the wireframe again, and we're going to select the same one that we did earlier for like the avoidance region. So in my case, my geometry is still turned on. If yours is turned off, you need to turn on edge curves again so you see these. I'm going to make sure that my wireframe and C-plane are selected. We want to make sure chain is selected. And then I want to go ahead and grab that chain right there. Wraps all the way around. And that's explained on page 76. It's all good stuff. Now the direction is different on the PDF, so let's go ahead and switch that. So you see how the arrows pointed this direction here. If we, which one reverses it? This one right here. So the start and end reverse, that'll change the cut direction so that it's going up instead of back the other way. And that matches page 76. Good. I'm going to click OK. So we are on contour. We have our chain. For a tool, we're going to use the 5/8 finish end mill that we used last time. And our comment to start with is going to be finish boss walls. And we'll add a Z- later when we know what it is. I may have been missing this. Force tool change on. What that means, so we just use tool number 7. If you click on force tool change in between, it's going to force to go back to the tool carriage changer. Even though you're calling the same tool out, it's kind of like a safety thing, so it still goes back to a tool changer, even though number 7's been used 2 times in a row. We're going to skip holder, go right to cut parameters. Our compensation type is wear. Stock to leave on walls and floors is 0 and 0. We're not going to change anything else. So number 82 explains wear compensation. Wear compensation offsets the selected geometry's coordinates before creating the tool path. So it is not necessary to put the D value in the offset register at the machine. The tool path will cut the feature to the correct size, assuming that no tool pressure is present, meaning it's not deflecting at all, with a D value of 0. So if you use wear compensation, it still allows the operator to adjust the size of the part by putting a value in the offset register. So if the pocket ends up being 2 thousandths too small, in this case when it runs the program, the operator could put a D value in of -2 to change that, so that it would end up cutting at the right value that it's looking for, rather than computer, which I think just doesn't allow you to add a D register in the machine. It just calculates it for you and you're stuck with it. We're going to disable depth cuts. That was on page 82, by the way, if you want to read through that. So now lead in and lead out on this one is going to be, the last time we did this, it's a little bit confusing, but it spells it out exactly what we're going to do on page 84. So we're going to uncheck enter an X at midpoint, which means instead of coming in at like the center of the radius, it's going to come in at the end point, or the next closest end point. We're going to take the gouge check off. Entries turned on. We want a perpendicular, which is the same thing. Yeah, line perpendicular. I'm sorry, they want tangent. So instead of coming straight in, it's going to roll into it. Our length is going to be 0.1. So we're not doing it by percentage, we're doing it by length. So we want to go to the second box and put 0.1, which should be 16% of the tool. And our ramp height is 0.010. So the ramp height is the distance between where the tool starts to feed at an angle down to where it's going to cut. So that is on page 84. Now for arc, again, we're going to change that to 0.1, which is 16%. Sweep 90. Helix height 0.010. And then we're going to throw all of these over to the exit point as well. So the way you do that is you just click on the arrow in between here underneath the tool where it's the visualization, and that throws all the same values over to the exit. So the line component of lead in and out is used to turn cutter compensation on and off. It must be bigger than the maximum anticipated cutter comp value that will be applied in the tool offset register at the machine. The arc component of lead in and lead out is used to ease the tool into the part, which alleviates the sharp change in tool pressure that would result from driving straight into the workpiece. Larger arcs are preferred as they ease pressure into the tool rather than slamming it against the part. Ramp and helix heights ensure the tool will not plunge on top of the finished floor, and this will prevent unwanted tool marks. So what this is doing is alleviating the amount of force that the part takes as the tool enters into the cut, is a long story short. And it also improves the surface finish and gets rid of witness marks and things like that. So you can read that again on page 86 if you'd like to review it. Breakthrough is turned off, multipasses and tabs are turned off. We're now looking at linking parameters. Clearance of 2 absolute, retract 1/4 inch absolute, absolute feed plane 1/4 inch as well. Our top of stock is still -3 now. And again, okay, so they have the feed plane again at -3. So basically it's just coming down to the part, and it's not going to ramp down from a 1/4 inch above everything. We can do that this time around just so you see the difference. So retract is still a 1/4, feed plane -3, top of stock -3, and then absolute, our depth is also -3.3. And we double check that again by clicking on depth and then just selecting a point on the part. Perfect. So now we can backplot this as well. Actually, before we leave, why not? So we know our z minus is going to be -3. So let's go ahead in the tool comment and just do -0.300 for z minus in the comment. We can now click OK, and we can backplot. So you'll see that it's the entrance to the cut is on the end of this radius here. This is the lead in and lead out that we did. Here's our clearance up here in the yellow. So now we can go ahead and run this and just check it out. Looking at it from the top, I want to make sure that we're touching the part now, which we are. And I also want to check from the front or the right and make sure that we're also touching the bottom, which we are. Perfect. So there's that little ramp up away. You see how it's not touching the part there, but when it's cutting, it's down here. Let's see, I can run it again. See that? So this is going to be, that's the little lift there that we did with the lead in and lead out. Good. Now the only thing we have left to do is chamfer. So we're going to use contour again. We're going to select the same chain as last time. No surprises there. So again, C-plane is selected, wireframe, chain, make the same pick, and it should go all the way around. I'm going to go ahead and reverse that again so that the green cut arrow is pointed up and away from us, which is great. Go ahead and click OK there. Our tool is now going to be a 1/4 inch 90-degree chamfer mill. Tool number 3. Let's reinitialize the speeds and feeds on that. And then the comment is going to be chamfer the boss. And boss walls, sorry. And then we're going to have a Z minus value that we come back in and put later. No holder. Cut parameters, we're going to change the contour type to 2D chamfer. Compensation type is where again. Width, we're going to put in 001. And our tip offset is going to be 0.005, which is actually bottom offset in the new cam. So bottom offset is now tip offset. And we're going to push out the cutter by 1 thou too. There has to be something in there, I believe. Stock to leave on walls 0.001. On page number 104 it explains this. So Mastercam does not allow a chamfer width of 0, but the chamfer is already defined on the model. So we're basically having to fake it. If it wasn't on the model, then we could put the real dimensions in. So setting chamfer width to 0.001 and stock to leave 0.001 creates a net effect of 0. So it's basically the same thing as putting 0 in there, even though it wouldn't allow it. So if the chamfer was not on the model and the desired chamfer was 15, the chamfer width would be set to 15, and the stock to leave on walls would be 0. So this width and this width cancel out is basically what we're doing. We're kind of faking it. And that's on page 104. Depth cuts unchecked. Lead in and lead out, we're going to basically have the same kind of stuff going on here. So our entry is tangent, gouge check is turned on, our length should be 100, in here, so it's different now because the tool width has changed, so we got to retype in our 100, sorry, that's 40%, and the radius is the same deal, I believe. Yeah, 0.1 again, so it's be 40% of the tool width, and then the ramp height should be 0. The radius is 100, yeah. Sweep 90, helix 0. So we're not doing that little lift up that we did last time. And then we're going to throw that over to the exit as well. So basically 40%, 40%, which should be 0.1. And then the sweep of 90, and then throw it over to the other side. No breakthrough, no multi-passes, no tabs. Now linking parameters again. Absolute 2, retract quarter, feed plane, we're going back up, so we want to keep that at 0.25 because we're cutting higher. We're no longer working on the bottom of that, so we want that to be higher. Our top of stock is 0 because the top of the part is 0, and our depth is -15. Perfect. So now we're going to back plot that. This one we got to really zoom in and kind of look at what's happening here. So I'm going to slow it way down. Here comes the tool, and I just want to make sure it's matching up with the chamfer, and it looks pretty damn good. Yeah, I'm happy with that. So now I just want to make sure it walks through or walks around the entire part the way it's supposed to be. Excellent. Good stuff. So we have checked everything out. So our final Z minus depth, which we get from the back plot, if I wasn't paying attention, we'll let that run. When you look down the bottom here, I want to pause it, open this up and look at information. There's our Z minus. You kind of got to open the box a little bit. So we see that our Z minus, while it's running like this, is Z minus -0.066. So that is the distance that we're going to put in the comment, in the tool comment for this. Z minus 0.066. Now we can do the solid verify. When you do the solid verify, we want to make sure that we select all of the toolpaths. So we're going to go ahead and click on Opt10G54. Oops. We want all of them to highlight. So if you click on that upper one, all 5 of those get check marks. Now we can go into the solid verify. We're going to want to go to verify and turn on color loop. That changes the colors of each cut. And I'm going to go ahead and play. And we can watch that happen. Perfect. Looks great. You see some witness marks on the floor. That's normal. That's just Mastercam not being able to, it's line on line, so it's showing a little bit of touching there, but no big deal. Good. So that's all done. And everything else looks good. So we're all set. So that's the end of the tutorial. So again, we've done this before. This is a little bit of reinforcement. You're going to do these a lot. You have most parts you're going to have some kind of boss on them. So you'll be using this set of tools a lot. And then I guess I go ahead and save this and submit it, and you're all set. So the lab is very similar. And again, next week will be a reaming tutorial, so it's going to be a little bit light again, more reinforcement stuff for drilling. But you're doing a great job so far, so just keep up the good work. And if you have any questions, please email me, okay? Have a great week. I'll talk to you later.